Let's look at the first part of 5.4 homework. I'm just going to go over in this video 87, 93, and 95. So 87, indefinite integral of e to the square root of x over square root of x dx. So if we look at this, we look to see we have a exponential function e to the u. So then maybe e to the u is the rule that we want to use. If that's the case, we want to go through u substitution, and we simply want the square root of x to be the u value. And hopefully, its derivative will help cancel out this square root of x, which is sticking out as not part of the rule that we want for e to the u. Okay, so let's try that. Let the u value be square root of x. We want to rewrite this in the form that we can apply power rule to find the derivative, so x to the 1/2. Go through power rule, bring down power rule for derivatives, bring down the 1/2, and then subtract 1 from the original exponent. So 1/2 minus 1 is negative 1/2. Rewrite this as 1 over 2 root x, cross multiply, solve for dx, which is 2 root x du. We make our substitutions. E to the u, now we only want this exponent, the exponent square root of x get replaced with u. We don't want this square root of x to get replaced with u, because we want this to cancel out. And it does cancel out. Dx gets replaced with 2 root x du. Root x's cancel out. Pull the 2 in front as a coefficient, so 2 times the indefinite integral of e to the u du. And integral of e to the u is just simply going to be e to the u plus c. Tack on the coefficient, and then rewrite our solution in terms of the original variable x. Okay, 93. This is similar to a problem that we saw on the class examples. Okay, when you see terms like this, usually your u value is going to be sitting in the denominator, which will help cancel out the numerator. So we let the u value be the denominator, and we go through the individual derivative rules that we know. The derivative for e to the x is simply e to the x times 1. 1 is the derivative of x. So that's just simply going to be e to the x. E to the negative x becomes e to the negative x times the derivative of negative x, which is negative 1. And then we clean this up. The two negatives cancel out to be positive. So du over dx is simply e to the x plus e to the negative x. Solve for dx, and we get du over e to the x plus e to the negative x. Make our substitutions. Denominator gets replaced with u. Dx gets replaced with du. Sorry, there should be a dx here. Dx gets replaced with du over e to the x plus e to the negative x. These cancel out. We're left with integral of 1 over u, which is simply natural log of absolute value of u, which is natural log of e to the x minus e to the negative x. In this case, I'm not going to be very specific about having the e to the x being a positive exponent, because this was not presented that way in the beginning. So we can leave it like this, or we can bring it down in the fraction here as 1 over e to the x. Okay, 95. 5 minus e to the x over e to the 2x. So anytime I see one term in the denominator, I want to split up and see if that will help simplify the problem. So separate fractions, 5 over e to the 2x minus e to the x over e to the 2x. Okay, this, I can bring the e to the top, and I can go through, use substitution there. For this fraction, as long as I have the same basis, I can subtract exponents. So x minus 2x is negative x. So I have integral of e to the negative x dx. Now, these are two separate problems, so I'm going to treat these with different, both of these will require u substitution, but you see the u value are going to be different. So I'm going to treat these like two separate problems. So first, my u value for my first portion is just going to be negative 2x. Find the derivative, which is negative 2. Dx is negative du over 2. Make our substitutions. 5 times integral of e to the u times du over negative 2. Pull the negative 2 with the 5 out, so negative 5 halves, integral of e to the u. And integral of e to the u is simply e to the u plus c, and our u value is negative 2x, and we keep the negative 5 halves. So this is the antiderivative for the first portion. Let's look at the second portion here. Right? Again, it's in the same form, so we can pick out the u value to be what's sitting in the exponent. So u is negative x. Derivative is negative 1. Cross multiply, dx is negative du. We make our substitutions. E to the u times negative du. Okay. The negative gets pulled out in front, so we get negative e to the u plus c, and then our u value gets replaced with our original, replaced in terms of x, which is negative x. Now, when I brought this negative e to the u down, this negative is going to cancel out with this negative that is sitting outside the integral to be a positive. So that's why we have a plus e to the negative x, which is the antiderivative for the second portion. And since this is a general, since this is an indefinite integral, we have to include a plus c.